Hi, I'm Arjun Nair from Bangalore, India, and I want to talk to you about subatomic particles and string theory. So let's start right at the beginning. What are subatomic particles? See, man has been curious about things around him forever. And with this inherent curiosity comes some very big questions. But what's the biggest question? Well, that's easy. The biggest question is, what are we made up of? What's everything made up of? And the answer is atoms. We know that atoms make up everything in the known universe. But what are atoms made up of? And now we're fortunate enough to know the answer. Atoms are made up of subatomic particles. I'm sure everyone has seen a picture of an atom.
So here's an atom. That's the electron and that's the nucleus. The nucleus is made up of protons and neutrons. Protons are positively charged and electrons are negatively charged. That's the basic idea of an atom. Let's delve deeper now. It gets a little complicated, so hold on. As we go further, new subatomic particles appear. They are called quarks. Now quarks are interesting. They are point-like bodies that make up protons and neutrons. Their names are pretty funny too. There are 6 types of quarks. They are
Up quark, down quark, charm quark, strange quark, top quark, bottom quark.
Sorry about that. Anyway, other than quarks, there are some subatomic particles called leptons. There are quite a few different types of leptons as well. The list of subatomic particles seems endless. Photons, neutrinos, gravitons, etc. etc. I think by now we can see that there are a vast array of different kinds of particles. But do we actually feel the influence of these tiny particles in our day-to-day life? The answer to this? Of course we do. These subatomic particles show us that they really do, pardon the pun, matter by manifesting in the form of 4 fundamental forces: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. So let's talk about these forces. The most famous force is gravity. It's the force that attracts all bodies in the universe to all other bodies. It's the reason we're still on Earth. Second, electromagnetic force. This is the force created by moving electric and magnetic fields. It's because of this that we have transistors and electronics. It's the very reason you're able to watch this video right now or browse the internet. Strong nuclear force is the reason the universe still exists. It holds atoms together. If not for this force, everything would collapse. Something we obviously don't want. Weak nuclear force is given out by decaying atoms. Is the reason we have nuclear generators that can harness its almost infinite energy. But with these different forces comes another important question.
Welcome to question time. Today's question is, what makes subatomic particles so different? They all have such different forces. But why? Let me tell you.
Until not too long ago, scientists said it's because they simply are fundamentally different according to nature. Here's where string theory comes in. String theory suggests that all particles, even the smallest subatomic particle, has the same fundamental building block, a string. These strings vibrate and oscillate in different ways to make different particles. Imagine a rubber band. Now just twang the rubber band and it's going to form a particle. Now maybe twang it with a little more force or a little less force. It's going to vibrate and oscillate in a different way, and this will create in turn another particle. As you can see, string theory can unlock a lot of great secrets for the future.
Whatever I have said today hasn't been confirmed yet, but I am very sure it will have a significant impact in the future. I had a lot of fun putting this video together. I hope you had as much fun watching it. Thank you.